The lesson today, as you could see, it speaks about the something you will learn related to the energy part that we got before. The objective for this lesson is to explain the mechanical energy, what is the mechanical energy means, and also what the mechanical energy means, and also how could they relate the mechanical energy is related to the kinetic energy, potential energy that's happened when you sum both of them together, and also we have to solve problems on mechanical energy at the end. Mechanical energy, if we want to go through it, he said here the energy that is acquired by the objects upon which work is done. Okay, and to make a work and to complete it by using the energy, it has to get the two types of the energy working together at the same time. So I said here mechanical energy, it's the energy that is possessed by an object due to its motion or due to its position, which means it can be either the kinetic energy or potential energy, or both of them at the same time, but they have to give me at the end the same amount. How could we understand this? Mechanical energy is the sum of both of them together. As an example, if you are working with a mechanical energy to just climb a mountain or something like this, we said that to go through this mountain, you have like 10 joules to be used in the mechanical energy. So if you are moving very fast, we said that you have 10 kinetic energy. 10 of the mechanical energy is considered as kinetic energy. And while you are moving up, you are losing an amount of the kinetic energy until you reach to the top of the mountain, where you can say at the end of this journey, you will find that all of your kinetic energy has changed to be potential energy. And on the top, you will have a 10 joules of mechanical energy, which are 10 joules of the potential energy directly. But while you are moving up, you are taking some of the joules from kinetic energy and you transfer it to be potential, which means we said that mechanical energy is 10. You have used, as an example, 8 joules of kinetic energy, and at the same time you have used 2 joules for potential energy. By continuing moving, you are losing kinetic energy 7, and then potential energy will be 3. At the end, they both must give me the total number, which is 10 joules of the mechanical energy. The principle of the conservation of mechanical energy says that the total mechanical energy in a system stays constant, doesn't change, as long as the only forces acting are conservative forces. The equations that we can use here inside this mechanical energy to be brought is the mechanical energy equals the sum of potential energy plus kinetic energy, and potential energy is being somehow calculated by the mgh, and also kinetic energy is being multiplied by half mv power to 2. That gives me mechanical energy. M is the mass, g is the gravity, v is the velocity, and the h is the height. The units for the energy is always joules. So I said here as an example, the mechanical energy of a ball gives me the ball ability to apply force to like order to cause it to be placed. Because here the massive ball has mechanical energy in the form of kinetic, it's able to do work on that. So mechanical energy is the ability to do work once you are finished. He gave me here an example, as you could see. 1.8 kilogram book has been dropped from the top of the football stadium. If the speed is 4.8 meter per second, when the height is 2.9 meters above the ground, what is the mechanical energy? If I want to answer something like this is the mass that he gave it to me, and here's the velocity that he gave it to me. This is the height. We said that mechanical energy equal potential energy plus kinetic energy. Mechanical energy here equals mgh, and plusing here the half of mv power to 2. You remove the m and you put 1.8 here, 1.8 there. The g is already with 10. Height here, you give it to me 2.9. And the velocity will be powered for 2. You calculate this side first, which gives me 52.2. You calculate this side, which gives me 20.74, and the total is 72.94. Another example here, 28 kilogram child on a swing that is traveling at 4.82 meter per second. What is this gravitation? What is his gravitational potential energy if he has 315 joules of mechanical energy? So mechanical energy, it equals for me potential energy plus kinetic energy. I will transfer the kinetic energy to the other side, okay, with the changing of its magnitude here to the negative. So mechanical energy minus kinetic energy gives me potential energy. Mechanical energy is already 315. Kinetic energy, I have to bring it. He gave to me the M, which is 28, and the V, which is 4.2. You will power both of to 2 and gives me at the end potential energy, which equals this number. He asks me at the end, this is the potential energy. If he increases the question and said, bring for me the height, so you will transfer to number to potential energy equals for me mgh. M here is 28, G is 10, height is needed, and potential energy we already have it here, 68.04. Then you calculate it by dividing the 68.04 over 280, gives me at the end of the height. Okay,